this problem is, it talks about a man pushes on a piano, and the piano is on a ramp, and the piano is moving at a constant velocity down a ramp, and the ramp is has an incline. In my question, it's about 11 degrees. So what I'm going to do is draw a ramp, and the incline of the ramp is, I'm going to call it theta. In my question, theta was approximately equal to 11 degrees. But it's going to be some angle. It could be different for everybody else. And I'm going to pretend this ramp is finite in length. I'm just going to mark it there. And we are going to worry about vertical and horizontal forces. So I'm going to approximate my ramp with a triangle there. I know it's at an angle, and I know the piano is on the ramp. So I'm going to draw the piano boringly like a box, and there it is. One thing that never changes is that this piano is going to have a weight downwards. Weight always points downwards. Weight is equal to mg. That never changes. This is the force of gravity downwards. The second thing that doesn't change is that there's a normal force perpendicular to the surface. Normal forces are always perpendicular to the surface. And if the surface is at an angle, the normal force is going to be at an angle. If the surface is flat, it's still going to be perpendicular and it'll be vertical. And I can push on this wall and the normal force will be perpendicular to the surface. If there's friction here, and there isn't in this problem, but if there was, it would run parallel to the surface. And here's the next complication with tilted problems on ramps, is our perspective is taken away from, it would be typical for us to draw a coordinate system like this, where we have y is vertical and x is horizontal. But the orientation that is most important now is this perpendicular orientation and the parallel orientation to the surface. So I'm going to not use that set of coordinates. I'm going to draw a new set of coordinates, one where one axis is parallel and one where the other axis is perpendicular to the surface. This is a more important and more descriptive coordinate system. If you don't want to use the symbols parallel and perpendicular, you can just call this x, call this y, but the point is, and it's a dramatic point, is that our perspective is now, we're going to consider this, quote, horizontal motion, but it's motion parallel to the surface, and we're going to consider forces and motions perpendicular to the surface. Because, well, you'll see it has lots of utility. It's a little bit difficult to work with, but if you tried to work with a coordinate system that stayed rigidly to the vertical and horizontal relative to, well, your own perspective and the ground, it's actually more difficult. So try to get used to seeing an angled surface and thinking about orienting your thoughts more in perpendicular and horizontal motion, more than what you standardly think of as vertical and horizontal. Think of it more as parallel and vertical. I mean, parallel and perpendicular. Okay, I better stop again.